All right, guys, let's look at lesson 4, which is calculating molar volume. We have a law that's called Avogadros Law that says the volume of a gas is directly related to the number of moles that are in that gas. We're talking about this separate because gases are going to be different kinds of compounds that you're going to come across, and they don't behave the same as solids and liquids like we talked about in the beginning of the year. The one thing you do need to know is that 1 mole of gas has a volume of 22.4 liters at standard temperature and pressure. So let's remember, what is standard temperature and pressure? Standard temperature and pressure, so when they're at the same temperature, the standard temperature is 0 degrees Celsius or 273 degrees Kelvin. And when they're at standard pressure, they're at the same pressure, and that's 1 atm or 760 millimeters of mercury. So how are we going to convert from moles to volumes? We're going to do the same 3 steps that we have been doing. Okay, we're going to write down what we were asked for, write down what we were given, and then apply factors to convert. So let's look at an example. What is the volume occupied by 2.74 moles of N2 at STP at standard temperature and pressure? So we want volume of N2, we're given moles, and we know that 1 mole of N2 is equal to 22.4 liters of N2. So we're going to start off with what we're given. We're going to multiply by our conversion factors. Moles are going to cancel. And we're going to do 2.75 times 22.4, and we're going to get 61.6. We have 3 sig figs of the numbers that we start off with, so we need to end up with 3 sig figs. So that is correct. Let's look at example 2. What is the volume occupied by 7.56 moles of oxygen gas at STP at standard temperature and pressure? So again, we want volume, we're given moles, and we know that 1 mole of O2 is equal to 22.4 liters of O2. So what we need to do is we need to set it up. So start off with what you're given, which is 7.56 moles of O2. Write your conversion so that moles go on the bottom so that they cancel, and then multiply into your calculator. So 7.56 times 22.4 is going to give you 169 liters of O2. This has 3 sig figs because 7.56 has 3 sig figs. So let's look at a practice. What is the volume occupied by 0.145 moles of H2 at STP? Pause the video, answer this on your own, and then unpause to check your answer. Great, well, welcome back. So you are given 0.145 moles of H2. You want your volume. You know that 1 mole of H2 is equal to 22.4 liters of H2, so we're going to set it up like we've been doing for the other examples, so that we start off with 0.145 moles times 22.4 liters over 1 mole. Moles are going to cancel. We're going to be left with 3.25 liters. This has 3 sig figs because this has 3 sig figs, so you know you're good. Let's look at a second practice. So what is the volume occupied by 0.687 moles of F2 at STP? Pause the video, answer this on your own, and unpause to check your answer. Great, well, welcome back. So what did you do? You should have started off with what you wanted, which is volume of F2. You have to next do what you have, which is 0.687 moles of F2. You need to know your conversion factor, and then you set it up. Moles cancel. We end up with 15.4 liters of F2. Awesome. 3 sig figs here, 3 sig figs here, so we're good. Now let's look at the check your understanding. What is the volume occupied by 3.33 moles of helium at standard temperature and pressure? Try this tonight, and I'll give you the answer tomorrow in class. Now let's go the opposite way. So now we're going to go from volume to moles. So again, we're going to follow the same 3 steps, so let's go right into an example problem. So how many moles of chlorine are in 2.5 liters of chlorine gas? We want moles, we're given liters. We know that 1 mole contains 22.4 liters, so we're going to set it up. And this time liters is going to go on the bottom instead of on the top because we want liters to cancel. And then we're going to end up with 0.112 moles of chlorine gas. This has 3 sig figs because 2.50 has 3 sig figs. Let's look at example 2. How many moles of nitrogen are in 6.5 liters of N2? What do we want? We want moles of nitrogen. What do we have? We have 6.5 liters of nitrogen. And what do we need to know? We need to know that 1 mole of nitrogen is equal to 22.4 liters of nitrogen. So we're going to set it up so that liters cancel. Liters needs to go on the bottom. What we're given needs to start off on the front. Liters go away, so we know we're good. Plug it into our calculator. 6.50 divided by 22.4. We get 0.290. 3 sig figs here, 3 sig figs in our answer, so we're good. Try this practice, and then we will check it when you're done. So pause the video, try it, and then unpause to check your answer. Great, so how many moles of oxygen are in 13.2 liters of oxygen? Okay, so you should have known that you wanted moles. You were given liters. You know your conversion. So when you set it up, you should have set it up again so that liters is in the bottom. And you solve for 3 sig figs, which is 0.589. Let's look at practice 2. How many moles of hydrogen are in 9.50 liters of hydrogen? Okay, pause the video, unpause it when you're ready. Great, well, welcome back. So we want moles of hydrogen. We're given liters of hydrogen. We know that 1 mole is equal to 22.4 liters. So we set it up so that liters is on the bottom so that they cancel, and plug in and we get 0.424 moles of H2. Check your understanding too. So how many moles are in 6.92 liters of fluorine gas at STP? I'll give you the answer for this one tomorrow.